Have you ever stopped to think about what's really going on inside your phone when you send a text? Or inside an ATM when you pull out cash? It's kind of wild, right? Well, there's this hidden conversation, a secret script that all the different parts are following. And today, we're going to pull back that curtain and take a look at the script.
So to get our heads around this whole idea, let's start with something super simple. An everyday thing we've all done, buying a snack from a vending machine.
I mean, on the surface, it seems dead simple. You put your money in, you press a button, and boom, a snack pops out. Easy, right? But that's just the tip of the iceberg. It's only what we see from the outside.
But think about it. What's really going on in there? How does the part that accepts your dollar bill talk to the brain of the machine? And how does that brain check if your chips are in stock and then tell that little corkscrew thing to turn just the right amount? That right there, that's the hidden conversation. See, before anyone even thinks about writing a single line of code, engineers have to map all of this out. They need a plan, a blueprint for that conversation to make sure every single part knows exactly when to talk, what to say, and what to do next. And that's where this really powerful tool comes in. It's called a sequence diagram. And honestly, the best way to think about it is like a movie script or maybe a comic strip, but for software. It clearly lays out all the actors, the order of events, and all the little messages they pass back and forth to get the job done. Okay, so the number one rule of sequence diagrams, the most important thing to get, is that time flows down. The story starts at the very top of the page, and it just unfolds as you go down, one interaction after another. It's literally a timeline of the conversation. And this, right here, this is the whole reason these diagrams exist. On the left, you've got what you do. Press one button, B4. But look at the right. It's this whole flurry of internal messages flying around inside, validating funds, checking inventory, telling the dispenser what to do, calculating change. It's this exact complexity that engineers need to manage.
All right, so let's do it. Let's actually build out the script for our vending machine. We're going to map out that whole hidden conversation step by step.
Okay, every good script needs a cast of characters, right? First up, we have the customer. That's us. We're what's called an actor because we're outside the system. Then inside, you've got the whole crew. The controller, which is basically the brain, the money hardware, the display, the keypad, and of course, the dispenser. All these guys have to talk to each other. And action. The story kicks off when we, the customer, put some money in. Right away, the money detection hardware sends a message, a ping, to the main controller, basically yelling, "Hey, we got cash over here."
And check this out. This is our first internal interaction. The instant the controller, the brain, hears about the money, it immediately fires off a command to the display screen, showing us exactly how much credit we have.
And the conversation keeps going. The controller doesn't just stop there. It sends another message right after, telling the display to flash "Make selection." And now the whole system just pauses. It's waiting on us to make the next move.
Now here's a really cool detail. Not all these messages are the same. Some are what we call synchronous. It's like saying, "Hey, do this and get back to me, I'll wait." The sender literally pauses. Others are asynchronous, which is more like, "Hey, go take care of this, I'm gonna move on to other things." You don't wait for a response. Choosing the right one for each step is a huge decision for engineers. Okay, so mapping out the perfect scenario where everything works, that's the easy part. That's called the happy path. But let's be real. When does everything ever go perfectly? The real power of these diagrams comes from planning for when things go wrong. So let's think about a super common problem. You put your money in, you press B4 for your favorite chips, but the machine's empty. We've all been there, right? A poorly designed machine might just eat your money or freeze up. So frustrating. But a good script, a well-designed system, already anticipates this. Engineers build a plan for different outcomes right into the diagram from the very beginning. It's called an alternative path. And here's exactly how that logic looks on the diagram. First, the controller checks the database. And right there, the path can split. It's kind of like a choose-your-own-adventure book. If the item is in stock, great. We go down the happy path and get our snack. But if it's not, the script directs the system down the alternate path. Prompt for another selection. No freezing, no stealing money. It's brilliant.
And that's really the crucial takeaway. Good software isn't just about handling success. It's about gracefully managing failure. Thinking about all the ways things can break before you ever start coding, that's what separates clunky tech from the smooth, reliable systems we actually love to use.
Now, we've been talking about a simple vending machine this whole time, but I want you to zoom out with me for a second, because this concept, this idea of scripting conversations, is a fundamental building block of our entire modern world.
So let's just quickly recap the big ideas. These diagrams let us see the conversation, they help us specify the exact messages, they let us model really complex scenarios, and, maybe most importantly, they force us to plan for errors and alternate paths.
Because at the end of the day, that fundamental logic of mapping out a conversation, defining who talks to who, in what order, with what message, that's a universal principle in designing any system.
And this is where the scale just becomes incredible. The exact same diagramming technique that makes sure you get your bag of chips is used to map out the communications for a satellite control system. Let that sink in for a second. For a satellite, a message that's a millisecond too late or an error that wasn't planned for, well, that doesn't just mean you lose $1. That could mean a billion-dollar mission failure. The stakes are astronomically higher, but the core challenge is exactly the same, making sure every component communicates perfectly in the right order every single time.
So the next time you use an ATM, or send an email, or even stream a video like this one, just take a second to think about that invisible script running behind the scenes. It's a perfectly choreographed conversation, designed and mapped out, all to make an incredibly complex task feel simple. How many of those conversations have you been a part of just today? Makes you think, doesn't it?